Welcome to Math 108 Elementary Statistics. This is Dr. Gilbert Eyabi. The brief lecture today introduces MathStudio with respect to correlation and regression, which is chapter 5 of your text Discovering Statistics by Hawks. I already have enough information on Canvas on how to use your TI 84, 84 plus, 83 calculators to solve problems involving correlation and regression. As a matter of fact, I also have some information on Canvas on how to use MathStudio, but it's the outdated version or the old version of MathStudio. So today I want to show you how to use the new version of MathStudio. The way we're going to do this is by solving some problems from Hawks using MathStudio. So let's go ahead and start off by selecting scatter plots and correlation. Okay, well, question number 1 doesn't really deal with MathStudio, but we can still go ahead and answer question number 1. It says, determine if the correlation between the two given variables is likely to be positive, negative, or if they are not likely to display a linear relationship. The retail price of a particular model of television and the number of units sold at that price. So as the retail price increases, does the number of units increase or decrease? Well, you could argue this in several ways, but I think in general, if the retail price increases, the number of units sold would decrease, and that would mean a negative correlation. Okay, and that is correct. Now let's move on to next. Okay, we want to find or compute the correlation coefficient R, and here is our bivariate data set. So let's go ahead and take this data set down so we can put it in MathStudio. So we can call this first axis the x-axis and call this the y-axis. So we have 5.5 and 5, 6. 5.5, 8, 6, 8.5, 6.5, we have 9, 8.5, let me see, 5.5, 6 that, and 8, 6, 8.5, 6.5, 9 that. Okay, so let me go to MathStudio. So right here, this is my MathStudio app. So I go ahead and select my MathStudio app. And to open a new editing screen, just click on plus. That opens a new editing screen right there. I want to put in my x first. So just go ahead and select x. And here is your equals. And then you want to select your bracket right here. Okay, that is how we enter a list in MathStudio. We do not use parentheses or anything else. We have to use the square brackets. Okay, the values of x again are 5.5. comma, and 6, comma, and 8, comma, and 8.5. Let's see, 5.5, 6, 8, 8.5, comma, 9. Okay, let's make sure we have it all. 5.5, 6, 8, 8.5, 9, and then you hit return. So it has assigned this list the name x. Now, if you don't like the fractions here, if you think you might get confused, just go back here and hit enter or return the second time, and it gives it in decimals. Okay, that's how easy it is. Now, my list y is the list with values 5. Those are the values we got. And the next value was 5.5, comma. You separate this with commas, 6, comma, 6.5, comma, and 8.5. Okay. No, I think I got 8.5. Let's see. 5, 5.5, 6, 6.5, 8.5. Again, you hit return. And if you don't like that, hit return 5, 5.5, 6, 6.5, 8.5. Now, you do not sort the list. Don't put them in order because you mess things up. 5.5 goes with 5, 6 goes with 6, 5.5, 8 goes with 6, 8.5 with 6.5, and 9 goes with 8.5. Now, there are a couple of things we want to do, but for this particular case, all the one is the correlation coefficient R. Now, to get the correlation coefficient, there are three functions we are going to use here. All the functions start with LIN, linear. So just start typing LIN, and you see linear fit plot, linear fit model. Okay, linear fit plot, linear fit model. So select any one you want. And why not start with linear fit plot? So if I select my linear fit plot, so I'm dealing with the bivariate data set X, Y. So I just use my X, Y. Make sure if you did capitalize X and Y, make sure that will be the same thing here, because these are names given to these two lists. Okay, once I have my linear fit plot X, Y, I hit return, and guess what happens? So that's the first thing that happens. It actually gives me, let me double click on that. You see, it gives me my scatter plot. Remember, the first thing you learn once you start correlation and regression is to construct a scatter plot. It gives you a scatter plot, and then it actually goes straight to regression. It actually gives us our line of regression, the line of best fit. That's wonderful. And there are so many things we can do here as we move forward. You realize that if I wanted, for example, to find the value of Y for some particular X, all I have to do is hit trace. Okay, so right up there, we hit trace right there and put my finger anywhere on this line. And you see that tells me as X changes, Y changes, X changes. So if X is, say, for example, 9.15, Y is going to be 7.59. We use this to predict future values. Well, that is not exactly what we are looking for, but at least it shows us how to do a scatter plot. For your paper assignment, I expect you to do a scatter plot. Now, because the values are really big, what I expect you to do is do your scatter plot using either your calculator or your MathStudio. If you use MathStudio, all I need you to do is to print the screen and then submit the screen as your first work. You know, question number 1 for your next paper assignment says, do a scatter plot. So just print screen and submit that. That's good enough. In fact, if you are working on a Word document, you can print screen and insert the image as the answer to the first question. Then I think somewhere down the line, maybe number 5 or number 6 question, it says, you know, come up with the line of regression on the same axis as the scatter plot. And this will be the same thing. So if you're using MathStudio, this would serve as the answer to 2 questions. And while we're at it, if you're using a calculator, do the same thing. The procedures are there on Canvas. Follow the procedure. If you have a question, ask me. I don't mind doing a video with the calculator also if I have to. But once you get a scatter plot, take a picture of your calculator with the scatter plot showing very clearly, and then submit that as your answer for question 1. And same thing with the line of regression. I don't expect you to do it manually. So if I take linear, this time around, we already did linear fit plot. So let's try the linear fit model and see what happens. If I take the linear fit model, X, Y, and I hit return, you see what happens? It gives me A, it gives me B, and it gives me the correlation coefficient R. A and B, this will be the slope, and this is the y-intercept. It has the equation y equals ax plus b, where a is the slope and y is the y-intercept. And we will see questions that will require the slope and the y-intercept. But for now, all we need is the correlation coefficient, and it is 0.8496. 8496. Let's leave it at that for now. Let's go back to our question and see what kind of rounding is expected. We're expected to round to 3 decimal places. So that means it would be 0.8, well, it was 0.8496. So if you round to 3 decimal places, the 9 becomes a 10. So that becomes, and the 10, of course, bounces on the 4. So that becomes 0.850. Okay, and that's very good. And that is our answer. So I expect you to use technology in chapter 5. Now, there is a formula in your textbook on how to compute the slope, the correlation coefficient, and even how to compute the y-intercept. But I do not expect you to do all of that manually. So even in your homework, do not do that manually. Use technology to get the slope, the y-intercept, the scatter plot, the equation of the regression line together with the regression line itself. Okay, let's move on to another question. Okay, now for this particular question, you will not need technology to do this. You only needed technology for the scatter plot. For this question, it says, draw the scatter plot. Well, for the homework scatter plot, the paper assignment, you would need technology. But for Hawks, you do not need technology because the points are very few and they've already given you a template to work with. So let's see what we have here. Okay, so the first we have is, let's see, when age is 45, bone density is 360. So let's look at 45 and 360 is right up there. So 45 and 360, that'll be right there. And then when age is 49, we have 345. So when it's 49, we have 345. Looks to me like that's the point right there. And then when age is 53, we have 340. So 53, 340, that will be right there. And when age is 57, we have 330. So when it's 57, we have 330 right there. And when it is 65, we have 325. Okay, so we have to move that point down there. Okay, so if we haven't made any errors, that should be correct. Very good. And that is it. So that works. And the next is estimate the correlation in words. Is it positive, negative, or no correlation? So you can see that it was sloping downwards. So that would be a negative correlation right there. And then the next thing would be calculate the correlation coefficient. You see, that's all you have from the first part of chapter 5, the scatter plot and the correlation coefficient. Now let's go ahead and do the correlation coefficient one more time. Then we'll move to the second part of chapter 5 that deals with regression. Again, let's see if we can take down these points so we don't forget. The points are 45, 360, 49, 345, 57, 330, 65, and 325. Let's see. I don't have all. I missed one. 45, 360, 49, 345, 53. I missed 53. So 53 and 340 and 57, 330, 65, 325. Okay, let's put that on MathStudio. Okay. This time around, why don't I use uppercase? So uppercase X, and if I click on this 1, 2, 3, that should bring back this menu. So that is equal to, again, use square brackets right there. And the X values were 45, 49, 53, 57, 65. You hit enter. Okay, so that has been assigned. And let's go to Y. Again, let's take the uppercase. Hit 1, 2, 3 equal to square brackets. The numbers are 360, 345, 340, 330, and then 325, and hit return. 1, 2, 3, 4, 5. If everything is correct, again, you take linear LIN, and you want to take your linear feed model. So we select linear feed model, and our entries are uppercase X and uppercase Y. I hit return. It gives me my slope, which is negative 125 divided by 74. And my y-intercept is 430.878. And my correlation coefficient is negative 0.94915. 94915. So let's go and see what Hawks requires. So Hawks requires, again, 3 decimal places. So that would be negative 0.949. Okay, very good. And that is our answer. And the next question would be the exact same thing over and over again. Do the scatter plot, find the correlation coefficient. Okay, so that is it about the first part of chapter 5 using MathStudio. So let's go on and look at the second part of chapter 5, which deals with linear regression. Okay, a lot of words. But what I want you to remember or to catch is this formula right here. Your calculator would give you y equals ax plus b. MathStudio would also give you y equals ax plus b. Now, Hawks gives you y hat equals b0 plus b1x. Should you be worried about b0 and b1? No. All I need you to remember here is that whatever is attached to x by multiplication is your slope. So your slope here is b1 and b0 is your y-intercept. And why is this one called y hat? Well, some books call it y prime. It is because it is an estimated value. Okay, so this is the estimated equation of the line. And we get that because we are kind of, literally what is happening is like we are moving the points to the left, to the right to create a line. Okay, so it's approximate. Question number 1, find the estimated slope. You saw how we got the slope again. Just put in this as your x, put in this as your y, and take linear feed model, and you get a slope. So let's go ahead and do that. Get those points for me, if you would. The points again are 23, 39, 5, 43, 8, 44, 9, and 47, 10. 1, 2, 3, 4, 5. Make sure I didn't forget anyone. Okay, let's take those to our MathStudio. Okay, so x equals, we have 20. You see, I decided to start a new editing screen so there's no confusion between which one is x and which one is y. So that'll be 20, and we have 39, we have 43, we have 44, we have 47, and I hit return. It assigns that list the name x, and y equals, do the same thing with y, and that gives me 3, 5, 8, 9, and 10. 3, 5, 8, 9, 10. Hit return, it assigns that. And I take my LIN, linear feed. I select linear feed plot, and I want to get information involving the two data lists, x and y. I hit my return. Oh, I took plot. I should actually be taking feed model. I thought that's what I took. Okay, no problem. So linear feed model, x comma y, and my slope is a, my y-intercept is b, and my correlation coefficient is 0.90645, and so on and so forth. So, but the question wanted my slope. So my slope is 0.245055. So let's go see how many decimal places we're interested in. So that's 0.24505. Okay, it wants it in 3 decimal places. So that would be 0.245 because the 4th decimal point is a 0. Okay, very good. That's all. That's my slope. Now let's see. It's going to ask you for your y-intercept. Remember, we got all of that in one shot. That's our y-intercept right there is b. So our y-intercept is negative 2.4591157. Let's see how many decimal places. 2.45915. Okay, 3 decimal places. So that would be negative 2.459. Okay, that's good. So that is our y-intercept. The next question would be substitute the values you found in steps 1 and 2 into the equation of the regression line to find the estimated linear model. That means y equals ax plus b. According to this model, if the value of the independent variable is increased by 1 unit, then find the change in the dependent variable. Now, this question will be asked in several ways, and try not to fail the question. Basically, the independent variable is your x, and the dependent variable is your y. X goes along with a, and a is your slope. Okay? Slope is the rate of change. So let me put it in this simple manner. If I am driving at 50 miles per hour, my rate of change is 50 miles per hour. If my independent variable, which is time, changes by 1 unit, that's by 1 hour, how many miles do I cover? In other words, let's put it this way. If I drive from 10 a.m. to 4 p.m. at 50 miles per hour, and I don't change it, I stay at 50 miles per hour from 10 a.m. to 4 p.m., how many miles did I cover between 3 p.m. and 4 p.m.? 50 miles because I'm driving at 50 miles per hour. So whenever the independent variable changes by 1 unit, the dependent variable changes by the slope. And you might even see some questions where they would ask you if the independent variable changes by 1 unit, the dependent variable will change by, and you have multiple choice. The first option could be B0, B1, X, Y, and so on and so forth. All you have to remember is whichever one of those symbols represent the slope would be your answer. So in this particular case, your answer is going to be the slope. And the slope we got was, let's go back and look at it. Our slope, that is A, was 0.245, okay? So our answer is going to be nothing but our slope, which is 0.245, 3 decimal places. And that's it, and that's the answer. So watch out for this particular question. And then there is this other one also that is just a little tricky for nothing. Determine if the statement, not all points predicted by the linear model fall on the same line is true or false. Of course, this is the predicted linear model, the approximate linear model. If this predicted linear model predicts some points, then the points have to fall on the same line, and the line is known as the predicted line, or the line of best fit. So all points predicted by that line must lie on that line. Therefore, the statement, not all points predicted by the linear model fall on the same line would have to be false. Okay, we're almost done here. Now, find the estimated value of y when x is 43. So all we have to do is go back to MathStudio. Y equals ax plus b. So what is our a? Our a is 0.245. And use this to go up and back and forth or left and right. So if I click on this, the cursor moves to that point. Times x, remember ax plus b times x. X is, I think, 43. We'll go back and check. Plus b. B is your intercept, and we have it right there. So that would be negative 2.459. Okay, let's just go and check to make sure our x is correct. So yes, x is 43. So we have y equals a times x plus that. We just substituted this in a linear model so that we can find what the answer would be. And it gives us 8.06. Actually, I think I'm happy that I actually did this because I want us to go and play with it after this. Okay, so 8.076. So let's come in here. So that will be 8.076. Okay, and that is the answer. Now, let's go back and play with this a little and see. So for some reason, I started off by getting the linear fit plot, which wasn't necessary, but let's see if we can use it. So let me shrink in my screen a little because I'm going to get some high values. So I take my trace. You can put your finger anywhere on the line and just move it until you get to where x is 43. Okay, see how it changes. So we're going, x is going to be 43. It's not going to be exact. That's why we like using the equation instead. So when x is 43, okay, that's going to be very tough, 43. Approximately 8.09. Okay, and what did we get again? We got 8.076. Well, that's because this is actually 43.05 something. But if we're rounding to the nearest whole number or the nearest 1 decimal place, it's pretty close. Okay, that's very good. So let's go back and answer the last question. Find the value of the coefficient of determination. The coefficient of determination is r squared. Okay, so whatever the correlation coefficient is, you take the square of that value, that will be a coefficient of determination. So if I go back to MathStudio, again, if you have this big screen, just go back here, and that takes you to my editing screen. So I do my parentheses. That's what R is. So maybe put the first 3 decimal places as was requested. So that would be 0.906. 0.906, take the arrow there, and then you want to raise that to the power, that's exponent. and square and hit return, and that gives us, let me write that down, that gives us 0.820836. 820836. So let's go back. Okay, it needs it in 3 decimal places, and that would mean 0.821 since it was 8208. So that'll be 8201, and that is correct. And then it repeats itself. Find the slope, find this, find this, find this, find that. Now, there would be a question there that would require you to find the error of prediction. The error of prediction would simply be the original value minus the predicted value. So for example, here, the original value or the observed value for us of unsupervised, when it was 5, the overall grade was 88. Okay. Now, if you do your linear model, they may ask you to find the predicted value when x is 5. You may end up with about 88.1. So what is the error of prediction? The observed value minus the predicted value. That would be 88 minus 88.1, which would be negative 0.1. Okay, so that's all. That's probably the only thing we have not yet answered with all of this. Remember, to find the error of prediction, you simply substitute the x value and you would get whatever the predicted value is for that particular x value. Then go back to your table and see what was originally observed. What was observed minus what is predicted is your error of prediction. And that actually brings us to the close of chapter 5. There is nothing more. Okay, so that is how we use MathStudio for chapter 5. If you have any question, email me, text me, call me, WhatsApp me, or whatever it is that you can do to get hold of me. Thank you, and God bless you.